All right, so today we're going to keep going on our multi-step equation concept. And really what we're going to look at here on solving absolute value equations. And this is kind of a special case because we have another unique type of solution. So like we talked about our special cases, sometimes there are one answer, sometimes there are no answers, and one time there's an infinite amount of solutions. Well, absolute value is going to introduce a new concept where now there are two answers to the same problem. So we're going to look at, and the reason kind of comes back behind absolute value. If you think about that for a second, the absolute value of -4 is 4. But there's another number that has the same absolute value, and the absolute value of 4 is also 4. So either way we can go, if we're looking at an absolute value equation, you have to take into account that -4 and 4 have that same distance from 0, and either side of 0 is 4 away. So we kind of have to apply that to mathematics, that there are more than one possible choice. And we know absolute value is the distance from 0, and that's the key to this concept. And with that being said, you can kind of start working into how to do this. So since absolute value equations are a multi-step equation, and you can see like 3 different styles of absolute value equations down below, the first thing you have to do is make sure that the absolute value expression is isolated. And that's what this is right here. This is an isolated expression. This one is not isolated, and neither is this. It's the only thing left on one side of the equation. Okay, so now that this one is here, we're going to set the inside equal to both the positive and negative numbers from the other side. So what that tells you is you're going to kind of split out the concept. You're going to keep the 5z, and you're going to say, okay, 40 is 40 from there, but you're also going to go 5z is equal to -40. So that's what it means by setting it equal to both the positive and the negative version of the number. Now we're actually going to solve both equations just like we normally would. Divide both sides by 5. And so this one, it says z is equal to 8. And over here it says z is equal to -8. And that's the kind of the key behind it, is being able to do this. And then you're going to write your answer as a solution set. And that's what this is right here. That's all this is saying you have multiple answers to the same problem. So I'd say in this case, z is equal to these brackets of -8 and 8, and then close off those brackets. That's going to be what you consider as your answer to the problem. Okay, so you get the concept, and now we're going to look at how do we take these and solve them as well, and that's going to be as we go through it. But what I want to start with is just practicing working through ones that are already isolated. So these are already isolated, so that's a check mark here. Okay, so you can see isolated just means it's all it is by itself. So if we're going to set this equal, we get rid of the absolute value sign and set equal to the positive and the negative value. And you can see this one's already solved, so you would say the answer is -2. 2 x is equal to those two numbers. And the same thing over here. So you have m, the absolute value of m. So we'd say m is equal to 14, and m is equal to -14. And okay, well, those are both solved. So you'd say the answer is -14 and 14, because they have the same distance from 0. Okay. So now let's kind of take it up a step and kind of, okay, now these are also isolated equations. Okay, you can see there's nothing, so what I mean by this, and I can clarify this one, there's nothing outside the absolute value. Okay, these absolute value notations, there's nothing outside them. So now it breaks up into the same 2 steps. W minus 3 is equal to 4, but w minus 3 is equal to -4 as well. And these are all in your notes. These are just different problems. I just didn't keep it in the same format. So we're going to solve them the same way. We'd add 3 to both sides. But now you can see, here's the thing that's going to, the first 2 examples, we got the same. We just got the inverse of the others. As we go here, this answer is w is equal to 7. But over here, this answer is w is equal to -1. And that's completely fine. That's the idea behind absolute values. Sometimes you can have 2 numbers that are completely different. But if you think about it, 7 minus 3 is 4, and that equals 4. And -1 minus -3, or minus 3, is equal to -4, and the absolute value of -4 is 4. So it's still the same idea. And this one's the same concept. And it's just like solving a two-step equation. So I'm going to get us started, and then I'm going to have you guys go ahead and solve it. So we would split it into 4n plus 2 is equal to negative 34, and 4n plus 2 is equal to 34. Now I want you guys to solve these and give me the two absolute value equations. Choose the correct answer, multiple choice answer, and we'll see how we do. All right, so let's walk through this. So we're going to subtract 2 from both sides on each time, no matter what we're doing. So I've got 4n is equal to 32, and over here I've got 4n is equal to negative 36. So now I'm going to divide both sides by 4. So over here, n is going to be equal to 8, but on this side, n is equal to negative 9. So we would say the answer is negative 9, 8, in brackets, n is equal to, and that's going to be our final answer. Okay, good job. So, and let's take a look at one. Now, these are also isolated. So what I'm going to ask you guys to do is I'd like you to try to solve 5 and 8. Make sure you choose the correct answer, and we'll check them in just a few moments. All right, so let's go ahead and get them solved. So d plus 1 is equal to 8, and then over here we're going to d plus 1 is equal to negative 8. So subtract 1, d over here is equal to 7, and over here is d is equal to negative 9. So you can say d is equal to negative 9, 7. And it doesn't really matter if you write 7, negative 9. It's just a habit of mine to put the negative first. And then the same thing here. So we're going to set it up as negative 2v is equal to, minus 5 is equal to negative 17. And negative 2v minus 5 is equal to 17. Add 5 to both sides on both equations, and we're going to get negative 2v is equal to, over here we're going to get negative 12, and over here we're going to get negative 2v is equal to 22. So now we're going to divide both by negative 2. So we get v is equal to 6 over here, and v is equal to negative 11, giving us an answer of v equals negative 11 and 6. And that, if you plug those in, you'll see those answers end up coming out the exact same way. All right. So this really is now answers the question, what if there's something outside the bars of the absolute value notation? So this is really going back and saying, okay, now how do I isolate? Well, it's the same way you would isolate a problem. But what you're going to isolate is pretend this is the only variable, that you want to get this isolated all by itself. So how do I take that apart? Well, I'm going to subtract 2 from both sides. So I'm going to get c is equal to 10. Now I'll split it up and say c is equal to negative 10 and c is equal to 10. And over here I do the same thing. Divide both sides by 6 first, and then I'd say, okay, now that I've got my absolute value bars separate, isolated, I'll split them up and go c is equal to 4 and z is equal to negative 4. And those will give us our answers. So the whole goal is to isolate these two. So let's take a look at number 12 together. The only thing outside is right here, and is the negative 2 highlighted. The z plus 3 is what I want to get all by itself. So it changes out this. So, and one of the things you can remember is we're working through the order of operations, right? And to solve a problem, we typically go backwards. So even though addition and subtraction is here, and you'd say, oh, I do that first, that's the constant, it's not, because it's inside a set of parentheses. So it's actually going to be the last thing you touch. So we divide everything by negative 2. So we get z plus 3, or the absolute value of z plus 3, is equal to 7. And now we're going to split it up. Z plus 3 is equal to 7, and z plus 3 is equal to negative 7. Subtract 3, so I get z is equal to negative 10 here, and subtract 3, and I end up getting z is equal to 4. So my answer is going to be negative 10, 4, and that gives me this idea of how to kind of walk through these problems. Let's take a look if there's more stuff outside the bars this time. Okay, so you can see there's multiple steps outside the bars in both of these equations. But again, we're thinking in terms of PEMDAS. So as our solution set, we're going to work our way back up to solve. Okay, so remember what's in here. Then once we get inside parentheses, we work our way through the order of operations again. So the first thing we're going to handle here is we're going to do what? So if I've got 2w, the absolute value of 2w minus 4 divided by 6, I'm going to multiply both sides by 6. That's going to let me isolate the absolute value notation. Once I've got it isolated, then this is that isolated step. 2w minus 4 is equal to 18, and 2w minus 4 is equal to negative 18. It allows me to solve the problem. Add 4 to both sides. 2w is equal to 22 on this side, and 2w is equal to negative 14. Divide by 2, and we get w is equal to negative 7. And divide by 2, and we end up with w is equal to 11, giving me my answer of negative 7, 11 as my answer. Now over here is the same idea. And we're still working through the order of operations. So order of operations as I go up, the first thing I'm going to do is remove the constant, and here it is. Okay, so I'm going to add 6 to both sides. So I get 7 times the absolute value of 4n plus 8 is equal to 112. Divide both sides by 7. Cancels there, and 7. So I end up going over here, I go, okay, it goes into it 16 times, so 4n plus 8 is equal to 16. And then that allows me to split my absolute value and solve them just like I did before. So what I'm going to take a look at is we've already looked at 13 and 15. So I'm going to solve number 14 to complete, or 16 to completion, then I'm going to ask you to try number 14. So let's work our way through this. Remember, the key to everything is this order. So I'm working my way back up. So add 24. So I'm going to left with 3 halves times 4r, the absolute value of 4r minus 4 equals, now we're over here at 3, then we multiply by the reciprocal. Okay, those cancel, so I'm left with 4r minus 4 is equal to 2, and 4r minus 4 is equal to negative 2. Add 4, add 4. And these take up a good amount of space, so kind of keep that in mind as you write. Is equal to 6. Then over here we've got 4r is equal to 2. So I'm going to divide both sides by 4. And these are perfectly fine to have these fraction answers. R is equal to 3 halves, and R is equal to 1 half. So I'm going to say my answer is 1 half, 3 halves. It's my multi-step equation, so R is equal. Now I'd like you guys to solve number 14. Be sure you check your answer and click the right multiple choice answer, and we'll see how we did. All right, so we're going to add 3 to both sides to solve first, giving me negative 10 times h plus 5. The absolute value of h plus 5 is equal to negative 80. Divide everything by negative 10. So I get h plus 5 is equal to 8, and h plus 5 is equal to negative 8. Solve by subtracting 5 all the way across. H over here is equal to 3, and h over here is equal to negative 13. So I'm saying h is equal to negative 13 and 3. And that gives you your answer to work your way through them. So we have a couple other concepts here, and what I want to look at is there is a special case here as well, and I want to talk through it. So the absolute value of a number is equal to negative. And one of the concepts behind this is, can the absolute value ever be negative? And if you go back to distance from 0, distance can never be negative. So this one actually happens to be a no solution problem. So as you solve the problem, as you isolate, once the variable is isolated, okay, and it's the same thing over here. Once I divide both sides by negative 3, I'm going to get 2x plus 1 is equal to negative 7. And these don't work because an absolute value can never be negative. So one of the explanations is once you have it isolated, the absolute value cannot be equal to a negative number once it is isolated. And the key to that statement is right here, is it once it is isolated. You still have to solve, just like we did here. We took and divided both sides by negative 3. then I was left with that negative knowing there's no solution here. Okay, so now you're ready to tackle your absolute value homework. Reach out to me if you all have any questions.